All right. So tonight's lecture is our third night of JavaScript, and the good news is we have a lot less material to cover than the first two nights. So I hope you guys have had a chance to catch up on the craziness of last week. I know some of you attended the Q&As this weekend. And now we're going to move on to our next topic, which is all about classes and constructor functions. So the topics for tonight are going to build a lot on this idea of an object in JavaScript. So we'll start off tonight with a little review of objects, and then we're going to move on to exploring how to create classes, constructors, work with the prototype, all sorts of fun stuff. So let me share my screen, and then we will start by reviewing objects. Okay, and I will post the link to this replit if anyone wants it for reference. Right now, there's not a whole lot going on inside of it. So let's start off by reviewing objects. And specifically, I want to talk about something called object literals. We'll talk in just a moment about the technical difference between an object and an object literal. So an object literal is the whole thing where we create something with curly brackets, right? We talked about this on night one of JavaScript, that we have arrays, which are great for ordered lists, but when we need to keep track of information that, though related, kind of is related in a more nebulous way, we use an object. And that's because objects allow us to put labels on the contents. So if we had name equals Billy, age equals 36, let's see, full-time, false, etc. So all this information is linked together, but an array would not really be an appropriate data structure for this, because if we just had an array containing Billy, 36, and false, it'd be confusing what that information was talking about. So syntactically, when we create an object, we just use a set of curly brackets, and then we can put in these key value pairs, keys followed by colons, followed by the value, and then a comma. And the contents of an object really can be anything. You can have arrays and objects and objects, these primitive values, of course, and we are going to be talking tonight about functions inside of objects, which are a common and very useful thing. So I just want to review some of the basic properties of objects so we're all on the same page before we get into some of the more advanced new material. And I want to talk a little bit about some interesting features and gotchas with objects that we maybe breezed over in past lectures. So, all right, we have this object. If I actually reference the variable student, this is going to reference the entire object. But if I want to, let's just say if I want to know Billy's age, how can I access just the age property on the student object? Can anyone tell me in Slack? Student.age, exactly. So this is called dot notation. And as long as we explicitly know the name of a property, we can do this. So it's very similar to how we would look up length on an array. We just use this dot notation to reference a property. So anything that is a key on this object, but if we make something up, we're going to get undefined because there is no make something up key. So we can do this. We can use dot notation to reassign things. If we want to change Billy's age to 37, that works. So just like we would in any other variable, we can use a single equal sign to store a value in here. Or if we wanted to put a new property on, like student.likesJS, we can always add a new property. So we're not at all limited to the properties that we were given when it was first declared. We can add new properties on after the fact if we want. There's another way to look up items on objects, and that is bracket notation. So if we wanted to, we could pass a string in the brackets with the property name, and this will work as well. So normally we use dot notation. The one case where we really like to use bracket notation is, let's say we had a variable, something like property that was equal to the string age. So if we just did student.property, that's not going to work. We can't use dot notation here because it is assuming that the key is literally called property. If instead we want to use a property that's referenced by a variable, we have to use bracket notation. And then if we put property in here, it's going to resolve to that string. So this becomes really useful because sometimes our properties and keys are coming from variables that might be shifting. So those are the two ways to look up items, to change items, to add items to an object: dot notation and bracket notation. All right, let's talk about methods next. So, and we're really gonna talk a lot about this word method and what it means. So do you guys, we've explored methods before. You know, we've worked with string methods, we've worked with array methods. We've talked about a lot of cool array methods on last week. But okay, so who can tell me what is a method? Can anyone attempt to give me a definition of this term method? A function within an object. Beautiful. I see a few more people typing. So I think that I'm actually really excited to see that you guys got this one, because method is a term that a lot of the times we use. We know, we kind of understand, okay, arrays have methods, strings have methods, but we don't know literally what that means. So right now you might be slightly confused. Wait, when I say, you know, array.map, how is this a function within an object? Well, we're going to get to that a little later, but just know that the definition of method is a function within an object. So all methods are functions, but not all functions are methods. So if we want to create a method for student, like let's do say hi, all we have to do is set an anonymous function equal to a key. So this looks just like any of these other keys, except that we've set it equal to an anonymous function. One note is that we want to use, we do not want to use arrow functions on methods. There are some cases where it's fine, but your general rule should be if it's a method, don't use an arrow function. And we will talk later about why that is, but just for now, be aware of that. So we are going to say return hello. So we've put this method inside of our object, and just remember it is automatically a method because it's a function inside an object. I see the question, if we can't use arrow functions all the time, why use them? Because in most cases we can, and they're kind of a safe or a space-saving way of doing it. It's just a shorthand, basically. So that's why we use them. All right. And okay, so let's use this method real quick. So we could do student.sayHi. So notice that this method comes after a dot, kind of like these other methods that we are used to using on arrays and strings. And we see it works. So we can already see just visually that there's a parallel between some of the built-in methods we've worked with and this custom method we just wrote. And just to briefly address this, it seems easier to use the thing that always works. Well, nothing always works. So what I would say in response to that is part of becoming effective at JavaScript is learning these subtle things, learning when they will and won't work. Because a lot of the times, yeah, you could just know a few things in JavaScript and be able to build anything, but you'd build it the hard way. So really becoming a good JavaScript developer is actually about understanding the subtle nuances and knowing when something's going to work, when it's not, and being able to use these things in advanced ways because they'll save you time and energy. Yeah, so that's kind of my thoughts on that. If you personally hate arrow functions, you don't have to use them unless you're on a team that requires them as part of your style guide. All right, so we just created a method. Don't overthink it. It is literally just a function within an object. But it's about to get a little more complicated as we go forward. So, all right, let's go ahead and let's actually talk about, okay, sorry, getting organized. Let's copy this object or talk about how references work with objects. All right, so here's something that's kind of weird and interesting about objects. So I'm going to create object 1. And I'm going to create object 2. All right, so here's my question for you guys. Are these the same object? Object 1, object 2, are they the same? Ah, you guys are so clever. No, they are not. And if one of you guys who is not responding no is going, really? How did they know that? You would never guess this if you didn't already know it, but apparently you guys have figured this one out. So object 1 and object 2 are not the same. If we try to compare them, we are going to get false. Sounds like someone is chopping something. Yeah, I really like that actually. They're like twins. So they look the same, but they are not the same. So what that means in terms of technical memory stuff, these are two different things stored at different places in memory. So when we compare something, we're really asking, does it reference the same thing? Now, if I went ahead and said, let x equal 5, let y equal 5, these are considered the same because they are there's only one place that 5 lives in memory, and they're referencing that same thing. So with primitive types, if you declare them separately, they're still going to be equal. But with objects and arrays, it's a little different. So if we want to do, let's do this. So now these two things are the same because I actually assigned object 2 with a reference to object 1. So they still look the same, but now they are actually exactly the same. But there's a problem with doing things this way. So let's go ahead and console log each of these. One second. All right, so right now they look the same. If I did this, if I said object 2 dot key equals other value. Now this is a really strange thing in JavaScript when you're not used to it. It can be very useful as well when you get to React. This is a critical thing that's going to help React work. But here's the problem with these two things referencing the same thing in memory. So notice that I changed the key on object 2, but it affected object 1 as well. So this is just a gotcha you have to be aware of, which is that to change something on one object will affect any other variables that reference the same object. So once again, if we think of these like twins, if these are, so in this case, these are not twins. They're literally the same person. So it's like two different references to the same person. If that person gets a tattoo on their face, it's going to affect, well, the metaphor is breaking down because I don't know what references would be in the real world. Yeah, it's just like two different names. So if this guy has two different lives, if this dude is living two different lives and has a family over here in one city and a family over here in the other, if he gets a face tattoo in one city, he's still going to have it when he goes to the other one. So yeah. But so if you ever want to actually copy an object, you can do that. You just need to do this object.create thing. So we'll have to use this later tonight. I'll show you a use case for this. But if you ever want to not just have two variables referencing the same object, but actually have two different copies of the same object, you have to use this object.create method. So now, actually, I wish I hadn't gotten rid of my console logs. Let's go ahead and change this. So now object 2 is a copy. It's like we've cloned it. So when we run this, notice that this changes object 2, but object 1 stays the same. So just another important thing to be aware of with, with objects. All right, actually, yeah, let me see if we have any question so far, and then I want to introduce the last important, very important concept involving objects that will come up again and again tonight. All right, let's see if you guys have any questions about what we've covered so far. Okay, can I re-explain bracket notation? Sure. So bracket notation is just another way of referencing values on an object. So the rule with bracket notation is that you have to put the name of the key in quotes. So instead of just passing key in here, this would look for a variable called key. So when you're looking something up using bracket notation, just make sure you pass a string in with the name. So this will give us, so this and these two lines of code are equivalent. These do exactly the same thing. Normally we would use the dot notation version. It's just, it looks nicer, it's slightly less characters. But the use case for this is, let's say we had a variable that was let prop equal key. So sometimes we'll have a variable, maybe it's a parameter on a function or it's coming from some other file, but we'll have a variable that references the name of a key. So prop is not the name of a key in our object, but key is. So the important thing is that prop references a string that is a key name. So if we pass prop in here, that works exactly the same as if we had just passed the string in. So the rule for when to use each of these is use dot notation when you literally know the property name, and use bracket notation when you have a variable that references the property name. So those are the two different use cases. Most of the time for right now, you will be using dot notation, but sometimes in functions, you might have to use bracket notation instead. All right, so let's talk about the keyword this. So we're kind of done with our review of objects, and I'm going to introduce the first new concepts of tonight. And I will warn you, this is a really sophisticated and subtle concept in JavaScript. I think this is one of the hardest concepts to grasp. So be aware I am introducing this concept right now. We will explore this concept throughout the next hour and a half. So if it doesn't fully make sense right now, that's totally to be expected. I want to show you it to start, and then we'll be exploring it throughout this whole lesson. And that's the idea of this. So I'm going to change my student method. So instead of saying hello, it's going to say, hello, my name is, let's switch these over to backticks. Okay, so then if we throw a console log here so we can see the result. So then if we run this, still have this value thing down here, but we see that hello, my name is Billy appears. So notice that I actually interpolated a reference to the name property on student here. Why wouldn't I want to just hard code in the name Billy? What's wrong with, what is wrong with doing this instead? Why is this bad code and what I just changed it from good code? Because values change, exactly. So if we did it this way, and then we actually reassigned the name, we'd be in trouble. But now what's nice is if we did something like, actually, Billy has decided he wants to be a little more mature and he's switching his name to William. This method will update automatically. So a lot of the times methods do work with other properties in an object. So we want to make sure that we're actually referencing the properties so that if the property changes, things aren't hard-coded into our methods. All right, and I see someone already said we could potentially use the code for another student. We will do exactly that later. So another thing that we can use that right now might seem a little silly, but later you're going to see why this is so important, is we can use the keyword this. So the keyword this is a complicated thing, and as mentioned, we're going to spend the whole night exploring different ways that we use this keyword. But for now, just be aware that this is interchangeable for the object that we're living in. So another good rule of thumb with this is this refers to whatever comes before the dot. So when we do the say hi method, whatever comes before the dot will magically become this. So for right now, using this works exactly the same as doing student.name. And we should get in the habit of using the keyword this, because as we'll see later, it's a lot more generalizable. All right, so that is my review of objects. Any final questions about what we've covered so far before we start to talk about constructors? The difference between backticks versus quotes. All right, let's go back here. So backticks allow us to do the string interpolation thing. So as long as we have backticks, we can put in a $sign and brackets and pass variables in. If I tried to do something like, let's go down here, quotes, this is a value, and then I did, you see how with the quotes, it's actually interpreting all of this literally. So the string includes the $sign, it includes the brackets, and object1.key is not read as a variable. It's just read as a string. So generally speaking, we would use double or single quotes when we're working with strings, but we use backticks when we know we want to interpolate in a variable of some sort. Any other questions? All right, we are going to talk about this later. This is way ahead of where we're at. So we will talk about this. Yeah, so this is one of the big use cases. We're going to talk about object.create, but we're going to do a lot to work up to this point. So I'm going to check this one off and just trust that this will be talked about later. All right, so let's go ahead and start to talk about when we might need a constructor function. And since we've been working with these monster objects all sprint, let's go ahead and use some of them now. So I'm going to create a couple of monsters here. So we'll do vampire equals name vampire, danger level 5. And then good old friend, the swamp monster. All right, as I am typing this out, who can tell me why the code I am writing is not very good code? What is wrong with what I'm doing here? Dry, it is not dry. I am repeating myself. So these are not literally the same objects, nor are they, yeah, they're not the same objects, but there's a pattern. So whenever we start to create things and we see this pattern arising, this should trigger senses, especially if we know that we might want to, you know, instead of just having 3 monsters, maybe we want 100 monsters. Maybe we are developing a game or an app for monster hunters, one of the two. So these things, I see another suggestion that they're not an array. An array of these might be nice too, but our first concern is that this is very repetitive. So it turns out that this is very common, and you've already seen this in some of your homework examples when you were working with runners, and then in the previous one it was cars. You've seen that there's this very common thing that happens where we have a bunch of objects with kind of the same format. Well, there is a right way or there is a bad way and a better way to create these. And the bad way is to just hard code them all in. So what we're going to do is create a class, a monster class. So a monster class will essentially be a template for generating monster objects. All right, so in this case, we're thinking about what do these have in common? What is the general rule for creating a monster? So who can describe, just based on these guys, who can describe what would be, and you don't have to use code or anything, but just in regular speech, what makes a monster object a monster object? It has a name and a danger level. Absolutely. So we want to create a template for these objects that have a name and a danger level. So let's go ahead and create that. All right, so a couple notes. This is called a constructor function. And a constructor just means it's designed to create objects. So this thing is not an object. And constructors, they are functions, but they have a couple slightly different properties. One thing is that constructors are capitalized. Now, you don't technically have to capitalize this. It would still work if you didn't, but this is convention. So when I say something's convention, it means that it won't cause your code to crash, but it's a cue to other developers about what's going on. So you should always capitalize constructor functions because it will help other developers recognize this is not a regular function. It's a special kind of function. So capitalize the name. There's a couple other more technical features of constructor functions that we will explore in a second. Use this and no return value. All right, so this keyword of this is about to come up. So what we can do is we can actually, just like a normal function, pass parameters into our constructors. So what do you think, just based on the way we described a monster object, what do you think would be the parameters for a monster constructor? If we have a template for generating monsters, what might change each time? Exactly, a name and a danger level. So this will help us set these values on our different monsters. All right, I'm just gonna call this D level. All right, so what we can do is we can now assign properties on our object. So we could think of this as being the object we are going to create. So normally we would think about writing a function like this that we'd have to actually create a monster item, assign some stuff on it, return it, but there's some shortcuts because we're working with a constructor. So what we do in here is we say this dot name, and then we set it equal to name. So we're saying create a name property on our new monster, assign it to the name value that's passed in, and then we'll do the same for danger level. So this is going to be the name of our property, whereas this is just a reference to the parameter. And then as mentioned, we don't have to return anything. So this looks a bit different than a normal function because we're not having to return anything and we can work with this keyword this to set things up. So that is our monster constructor. All right, what do you think is going to happen when we call monster? And let's try and create our vampire. Any thoughts on what's going to happen when I run this last line of code? We had a vote for nothing, a vote for return an object, reveal the function. So if we just looked up monster, this would reveal the function because this is a reference to the function. But if we call it, it turns out that we're going to get nothing. So this is undefined at the moment. And the reason is because we're calling it like a function. So if we call this thing like a regular function, there's no return values. So nothing's going to come back out. So there's one gotcha when it comes to these constructors, which is we have to use this new keyword. So always use new when calling a constructor function. So this is one thing that makes constructors and regular functions different. Now, if we use the keyword new, it's going to work. It's going to actually not only create this object, but it will keep track of the fact that this is a object of type monster. So it doesn't create an error if we call it without new. It just treats it like a function. But functions require return values. Yep. So this is what's called an instance. So a constructor is the template for creating these objects, whereas an instance is an actual, as the name suggests, instance of that constructor. So each individual monster would be called an instance. So here are instances. We can go ahead and store this one. I will comment these out since we don't want two variables with the same name. And then we can do swamp monster equals new monster. And zombie equals new. All right, I think vampire was 5. So look at that, 3 lines of code to generate these 3 objects. So 1 line of code per new monster versus all the stuff. And even if these things had 10 keys, 10 different properties on them, it would still just be 1 line of code. So when you're mass generating these things, it's really useful. Also, if you, let's say we wanted to change, so let me console log these real quick just so we can be sure they're working. All right, so let's see our 3 monsters. There they are. I'm gonna kill this line of code because it's getting annoying. And then notice that, let's say we wanted to change danger level to camel case for some reason. I just had to change that in one place and it automatically changed for all my instances. So yay, dryness. So what does this keyword new do? Well, it kind of fills in the gaps. So the keyword new creates an object called this, and then it returns it at the end. So we can leave off these 2 lines of code because the new keyword will automatically do that. The other thing it does is notice that this isn't just treating it as a regular object, it's actually keeping track that it was generated by a constructor. So that's another thing the keyword new does. And I think when I made this change, I just said yay dryness. So dry, don't repeat yourself. So when you don't repeat yourself, you can change one thing in one place and it'll change for all your code. Oh, camel case. Yeah, camel case is when, because it's like it's flat and then it's got a hump. So that's when you start lowercase and then every word that follows is uppercase. That's a fun little programming term. All right, so questions about constructors and instances. All right, I am confused. Sometimes console log is used and I've seen how it is just example. When can you not use console log to test code? You can always use console log to test code. It's just sometimes in the homework, it can be confusing to find where your console logs appear. Once generated, what would be the best way to put these newly created objects in an array? There's a few different ways to do it. Oh, cool. So 2 questions. So let me show you a couple different ways we might do this. One way would be, oh wait, where am I going? Sorry. So you could literally generate them in an array if you wanted to. So instead of doing it this way, you could do monsters. So if you were creating these mostly in advance, you'd probably just instantiate an array and just create the instances straight inside of it. There's nothing stopping you from doing this because this line of code just resolves to a monster. So we could do it this way. We could create them in their own variables and then push them to the array. That's kind of an extra step. So you really don't want them living in two different places. So, and then what the other thing you could do is, if you had to create one later, you could always do monsters.push. What should our next monster be? Someone suggest a monster. Anyone? Mummy. Ooh, I haven't done mummy before. So we could do mummy. Mummies are pretty chill. We'll give them a danger level of 2. Cool. So you can also create a new instance of a constructor within a push statement as well. So there's a couple ways to get these things in an array. Ooh, I like the chupacabra suggestion. All right, so I want to give you guys a chance to practice this. Let me make sure there's no other questions, and then I will let you guys try it out. All right, so what we have here is there's an example at the top of this, and let me post this link so you guys can start loading it. So what you'll do is you'll see a couple commented out objects that are not dry. So your job is to create a constructor function and then call the constructor function in order to create the instances. So at the end of each of these, you should have a constructor function and create instances based on the ones in the example. So on challenge 1, you will need to create a constructor for lattes, and then you will have to create these 3 instances of specific lattes. All right, and then you'll have to do the same thing with some spiders as well. So let's, I'll give you guys 5 minutes to work on this, and I'll see you back in 5. And let me just send another link to this guided if you want to see that for reference. All right. Good luck. I'll see you in 5. start to wrap that up. All right, so let's go over the solution. There we are. All right, so the first one is we're trying to create this latte class. And we can see that lattes have milk and syrup. So we can do milk and syrup. And one thing to note here, and if you didn't catch this little piece, that's totally fine because it's kind of subtle, is that syrup is defaulted to null. So we don't want our user to have to pass in null. So one thing we can do is actually, I don't know if you've seen this before, but we can actually do this up here in our argument. So if you didn't know this, that's totally fine, but just a little bonus extra thing. So this is saying if they don't put in syrup, set it to null. Otherwise, it's going to be undefined. So then we could do this dot milk equals milk, and this dot syrup equals syrup. The other way to do it is you could do syrup or null. So that's an alternate. So those do the same thing. But the or is kind of a more old school way of doing it. That is the ES6 way of doing it. And then we can create our instances down here. So we could do latte equals new latte, whole. We could even set our milk to be defaulted to whole if we wanted to. What was the next one? Mocha equals new latte, whole, and chocolate. And then the last one was soy latte. All right, and then we just want to probably throw a console log on here for each of these to make sure that they worked. So let's try it out. Cool. And look that our default worked and syrup is set equal to null on these instances where we left out that argument. All right, let's move on to spiders. It looks like spiders are coming back undefined. Did you use the keyword new? That would be the first thing I would ask. All right, so we will first need to create our constructor function. So spider capitalized equals function. And notice that legs, we really don't need a variable for leg, or we don't need an argument for legs because legs are always going to be 8. So we really only care about, is this venomous or not? So we can do this dot venomous equals, and then we can do this dot legs, and we can just hard code in 8. There's no reason not to. It's always going to be 8. Then we can create some instances. So we have Black Widow. And hobo spider. Oh wait, I have to console log my spiders. I was thinking about the whole losing a leg thing too, but once we learn methods, which is our next topic, we could create a method that would allow our spider to lose a leg, but we would assume that they probably started with 8 legs. I suppose there are also deformed spiders who maybe are born without 8 legs, but I'm sorry, spiders, we're not that inclusive in our spider constructive function. It's only for 8-legged spiders. All right. So there are our two spider instances. All right. So any final questions on constructors and instances before we move on to methods? All right, let's go ahead and talk about methods. So we already introduced this idea that methods are functions on an object, but methods become most interesting when we put them on constructors, right? Because theoretically, these objects might have methods that we want to use on them. So let's say that we wanted all of our monsters to have a surprise method. So, so all of these monsters should have, let's go back up here. We want them to have this surprise function. And all this thing does is it, come here, is it returns boo. So let's go ahead and put this on these guys. So if we wanted to make sure that every single instance of monster had a surprise method on it, what do you think we would do? Any thoughts on how we could accomplish that? We need to somehow include in this templating that there is this method. So any thoughts? Someone said the prototype. Someone's been reading Training Kit, haven't they? Yes, the prototype is the correct answer. But let's start with the obvious answer. So the obvious answer is not actually where we're going to end up, but it's a good place to start. The obvious answer would be, well, we create properties by adding them onto this. Why can't we create a method here? And the answer is, actually, we can create a method here. So we could do this dot surprise equals function, return boo. So we can do this. But should we? The answer is no, we probably shouldn't. And I'll explain why in a minute. But let's just test this out first. So notice that they all have a surprise function on them. And we can do if we want to, we can now do vampire.surprise. And it has this method. We can do zombie.surprise. And it works. We still get boo. We could even do monsters at index 3.surprise. This is our zombie, or no, sorry, our mummy. And it still works. So all these things have a method. It seems to be working. So what's the problem? Why do we not want to, then this is a much trickier question, but I'll see if you guys know this. Why would we not put our methods inside of the constructor like this? Anyone have any idea? I know some of you guys from the videos or Training Kit know this isn't the way to do it, but does anyone know why? Because it's going to run 100,000 times. Exactly. It uses too much memory. So it's not a huge deal when we only are dealing with 4 or 5 monsters. But let's say that we're developing software for the leading monster tracking firm in America. We have to deal with managing hundreds of thousands of monsters. So every time we create a monster instance, what actually happens is there is a brand new copy of this function created in memory. So this code runs every single time, and a new copy of literally this exact same function is in memory. So to be fair, memory is pretty cheap, but we still don't want to be writing code that's going to just be creating the same thing over and over and over again in memory. And to use a slightly less silly example than monsters, think about Facebook. So you won't really get into this until Unit 2, but where all this is leading is all the things you're working with on an app have JavaScript behind it. So I can tell you that somewhere in Facebook's code base, There is a class defining what is a user, what is a message, what is a comment, a post. There's probably a comment class somewhere. Think about how many comments exist. And those comments probably have methods, things like or delete or edit. So we can think, even just users is already a huge number. But then if we think about the sheer number of Facebook comments out there, if for every method, or for every comment, there's like 5 different methods, and we're creating 5 copies of those every single time someone comments on Facebook, that does start to become a problem. That's an insane amount of memory. So this is not scalable. The term scalable, I don't think it's come up yet. It just means that on a small level, this code is fine. But if we start to work with hundreds of thousands of data points, which is totally a thing in the real world, we're going to start to take up a ton of memory. So the prototype exists in JavaScript as kind of a workaround for this memory issue. So the answer is, should we? No, because of memory. So we will comment this out and put our surprise function in a different way. So at this point, if I try to run this code, I get an error because, oops. Well, I get an error because my comment is wrong. But if I run it now, I'm going to get an error. Monsters3.surprise is not a function because we're not defining it anywhere. So every constructor has a prototype. So there's a thing called monster.prototype. Keep in mind, monster with a capital M is not an instance of monster. This doesn't represent some specific monster. It represents the constructor. So these guys, these instances don't have prototypes, but the constructor function does. So every constructor has a prototype. What is a prototype? Well, to start, it's just an empty object. So, by default, your prototype's going to be an empty object, which is not that exciting, but let's just check and make sure it's there. Still having a problem with comment that out. Okay. But even so, we see that there it is. There's this empty object, monster.prototype. So the purpose of our prototype is it's a place for communal functions to live. It's like the library of methods. So this is where we want to define our methods. Oops, let's give this a second to catch up. Oops, come on. Okay. Oops, let's return boo. So this is a pretty subtle, amazing thing. So when we think about literally where we're putting this method, we're sticking it in an object on the constructor. So essentially, monster is an object. And that object has a prototype, which is also an object. And that prototype has a surprise method, which is a function. So yeah, this is not that intuitive. We have our method is inside an object, which is inside our constructor function. And then we somehow this is going to end up on the instance. Yeah, a little weird. So I'm going to keep this commented out because that's not valid code. But this is the idea. This is like the shape of our data here. So let's go ahead and do a little console logging and see what's happening here. So notice that these 3 monster objects do not have a surprise method on them. And it's correct, but it's also misleading. So it is literally true that each of these do not have a method on them, because that was the problem we wanted to avoid, was creating a bunch of different copies of the same method. But just because they don't literally have one doesn't mean they can't use it. So check out when I run this code, it still says boo. So how in the world is that happening? Well, what's happening is that whenever we call a method on an instance, it first looks inside the object. So it's first going to look inside of, let's do this on zombie. So if we run zombie.surprise, the very first thing that's going to happen is JavaScript will check zombie to see if there is a surprise method in here. In this case, there is not one. So then instead of giving up and erroring out, what it does is it actually looks inside of the prototype in Monster. So it's like a backup. So if it can't find the method inside the instance, it then looks in the constructor's prototype. And it finds it there, and then it can act. So that is the beauty of the prototype. And that's what the prototype was designed for. It's designed to be this backup so that we can have communal functions that technically only exist one place in memory, but can be used anywhere. So if you are struggling with this whole memory thing and that's not quite making sense, that's okay. Just be aware, like from a practical standpoint, all you need to know is do not write it this way. Do not put it inside of the constructor because it will use a bunch of memory. Instead, always do constructor name dot prototype dot the name of our method, and this way you'll save memory. So if you don't fully understand why, that's okay for now. But what you definitely need to understand at this point is that methods should always go on the prototype. All right. So someone is getting zombie.surprise is not a function. Is it on the prototype of your constructor? And is it set equal to a function? Is zombie an instance of monster? When you created zombie, did you do new monster? Oh, and is this code, does this code exist before your instances? That's actually a very important part too. This code needs to happen before you create your instances. Actually, I'm not 100% sure that's true. I'm pretty sure that's true, but I could be wrong about that one. It's probably a good rule though. All right, let's see. Your code looks good. Are you sure that you're not just seeing the old error? Like try clearing your console and then running it again. I might be missing. Sorry, I'm like. Did you spell surprise correctly? Ah, that's it. So on your constructor, you forgot you did surprise, not surprise. It's always the little things. All right, so I'm going to answer any questions about methods and constructors. We're going to take a little break, and then when we come back, we're going to talk about the keyword this and why it definitely matters in this case. All right, so any questions? Do you always have to set the new objects to variables? No, you don't. So you can, if you want to use them, you have to store them somehow, but you could also put them in an array. You could put them in another object. So probably the most common two things are either you're going to set them to, you could return them out of a function, but so you need to do something to store them in memory, but it doesn't necessarily mean assigning them to a variable. You could also put them in an array. So new is a keyword that triggers, it informs JavaScript. This is not just a regular, so what new is saying is this is not just a regular function, it's a constructor. So new makes sure that when this code runs, it runs in constructor mode, not in regular function mode. So there's this cool stuff that happens behind the scenes when you run a function as a constructor. So, and the keyword new guarantees that that happens. Is there a way to build the prototype methods into the constructor function? Yes, not with this dot prototype, because if you did this dot prototype, let me actually pull this over. So what would happen if I did, because remember the prototype lives on the constructor, and this refers to the instance. So this dot prototype would not give you the right spot. But in ES6, there is a way to do this that's a lot more clean, and that's what we're going to talk about on Wednesday. So there is a nice, neater way to do all of this, but we will wait until Wednesday to learn it. All right. What is a constructor? A constructor is a function that is designed to create a bunch of copies of objects that look very similar. Yes, we can do this, and this is what we'll be talking about after the break, so I'm going to skip this for now. How many times can we use prototype? As many times as we want. So we can put a bunch of different methods on. And we'll put a second method on that prototype after the break. So for example, let's do array prototype JavaScript. Cool. So all these array methods, notice that you might have tuned this out in the past or said, that's weird, I don't understand it. They all live on the prototype. So this prototype has all of these methods living on them. All right, so let's take our 5-minute break now, and then when we come back, we're going to talk a little bit more about methods and how the keyword this becomes really important when we're working with classes. So I'll see you guys in 5. All right, let's come back together and talk a little bit more about methods and the keyword this. So one question that kept coming up was, could we change this so it's something like vampire says boo? And the answer is we certainly can. So to do that, we would just have to, let's use backticks, and we could say this dot name says boo. Zombie says boo. And then we could do, we could also do, let's say, vampire. Vampire surprise, the best kind of surprise. So this is where the keyword this starts to become really important. Because remember in that first example where we used it, we could have just said student.name and that would have been fine, because we know we're in the student object. But in this case, we're writing a generalizable method that's going to be used on a lot of different objects. So there's no way for us to actually hard code in who.name, because it's going to be different things depending on who calls it. So we could do, so we can't hard code this in. We're actually required to use this. So this becomes really important when we're writing these methods on the prototype, because it's our way of accessing the instance without knowing what the instance is. So when we call zombie.surprise, zombie becomes this. When we call vampire surprise, vampire becomes this. Could we pass in a variable that says something like zombie says boo with glowing eyes? Yeah, we could do, if we wanted to, we could do some sort of modifier with, notice this is not a this thing, because it's just coming in as a parameter. So we could do vampire so vampire says boo with sharp teeth, or we could do zombie so that might be fun. Yep. Cool. So let me show you one other prototype example. So let's say that we wanted a kill count on here. So kill count is going to always start at 0. So just like the 8 legs situation, we can start our kill count at 0. So now when I run this code, notice all of these guys have a kill count of 0. But we want a way of incrementing this. We want some way of our monsters being able to kill things. So we can do a kill method. As always, this is going to go on the prototype. And then what do you think we would want to put in here? How would we go about increasing our kill count for each instance the kill is called on? Any thoughts? So we can't call the kill method well, we could if we were using recursion. But generally speaking, unless you understand recursion, you don't want to call the function you're declaring in the function you're declaring. We'd want to increase the count, definitely. So we need to increase this variable. Because if we just did count plus plus, count doesn't reference anything. So we do need to increase the kill count property, but how are we going to, still if we did kill count, that's looking for a variable called kill count, and there isn't a variable called kill count. There is a property called kill count. So if we want to reference a property, how do we do it? This dot kill count. So just like we use this dot name here, we're referencing a property on the object. So that means we need the keyword this. And I'll say that kill doesn't return anything. It just increments it. So, all right, let's go ahead and try that out. So if we do zombie.kill, maybe we'll give vampire 1 kill. This zombie's really going at it. And let's go ahead and just run these above the console logs. So let's see what happens. Notice that vampire's kill count went up, swamp monster stayed at 0, and zombies went up all the way to 3 because we called kill 3 different times. So this is a really common thing we'll do with methods, is we'll actually use methods to augment the property values. So in this one, we're just using the existing property name to print something, but it's totally common that we will use a method to actually change the value of a property. All right, so we have a question, is that dry? So you might say that this isn't dry because I just copied it 3 times. When you're just doing something 3 times, it's not the end of the world, but maybe it'd be better if we did a loop for this. But the prototype is definitely dry because we've written this function once and it affects all instances just from this one chunk of code. I also see question, is this like a closure? This actually came up in the Q&A today. It's not like a closure because I see there is definitely some similarities, but the reason it's not like a closure is because we could still say zombie.killCount and just reset this. We could just hard code this to 60 if we wanted to. So why closures are special is because they protect that value and there's no other way to change it. So I could just go in and manually change the kill count and that would be fine. All right, any questions are kind of coming in from different sources. How do you suggest organizing our non-prototype prototype code so they're readable to other developers? Honestly, the way you'll write it will be, the answer is going to change once you learn how to do it Wednesday, but for now, this is how I would recognize, or how I would recommend it, is you should have your constructor, and then beneath your constructor, you should have your prototype. So these two things should always go together. They should be next to each other. And what you'd probably have in a real world example is that there'd be a file where constructors are defined. So you would have, oh yeah, I just added kill count in the constructor with the other properties. That's where that came from. But yeah, so you would probably have a file that's just for constructors, and then your instances would probably exist in totally different files. All right, last comment on constructors. I mentioned, or sorry, on methods. I mentioned that we cannot use our, let's get rid of this real quick. I mentioned that you cannot use arrow functions here. That's because arrow functions mess up this binding. So, sorry, I see, I'm getting lost in my own code. So if I try to do an arrow function here, notice that kill stops working. So you can use arrow functions as long as you don't use the keyword this, but you should get in this, but you shouldn't get in the habit. So there was something that came up of, oh, that's annoying that we can't use arrow functions. I like things to be uniform. I wanted to comment more on that, but I thought I'd wait until this moment, which is I really like things to be uniform too, which you probably can't tell because I type like a spaz when I'm teaching. But when I'm actually writing code, I write like this, but then I go through and I organize everything because it helps keep me sane. So you guys get to see spazzy Diandra coding. But when I'm writing code for real, I go through and I make it really nice and uniform. So here's my rule is you should never use an arrow function for a method, but it'll still be pretty uniform because what's going to happen, as I mentioned, is all these prototypes are all going to exist in one file by itself. So everything in that file is going to look nice and neat and uniform. And then maybe other places in your code that are not designed for constructors, you can use arrow functions. So there will be mixed and matched in your code generally, but the places they appear will be pretty separate. So maybe that still bothers your uniformity sensibilities, but I find it still looks pretty nice and organized because these method functions tend to be off on their own in their own separate files. All right, So any final questions about methods or the keyword this before I let you guys try this out for yourselves? All right, already answered that. All right, so these are all out of order. Let me give you guys this next you do challenge. So in this case, I have already created, as you saw last time, your latte and spider function, and there's a person this time too. So for each of these 3 already created constructor functions, you have to create methods. So there is a method defined in each of these challenges. I think there might actually be, no, each has 1. So 1 method per constructor, which as mentioned, you can have many methods, but this assignment just has 1. So I'll give you 5 minutes to work on this. And a little hint is that you probably will want to create some instances so that you can test out your methods and make sure they're working. All right, so I will see you guys back in 5. All right, start to wrap that one up. And we'll go over the solution in a second. I'm going to cut your time 20 seconds early. I'm sorry. I apologize. All right, so let's take a look at creating some methods. So the first method we want to create is a latte method called drink, and it console logs yum. So we always want to put things on the prototype of the constructor. So latte.prototype.drink. And we can do console log yum. I'm just going to steal some latte code here. So we've got a couple latte instances, and we could do latte.drink. Let's try soy latte.drink. And we get yum in both cases. So next we want to give spider a method called bite, and it should return ouch if the spider isn't venomous, and return better go to the ER if the spider is. So in this case, we're going to have to use the keyword this. We start off by putting it on the prototype, as always. And this was bite, right? So we're curious if our spider is venomous or not. So we can do if this.venomous return, and notice that the first one was log, the second one said returns. So you do have to pay attention to what the instructions ask. So return better go to the ER, versus if it is not venomous, return ouch. All right, we can grab ourselves some spider instances from here. And let's try doing bite on each of these. We definitely want to see the different behavior. So the first one is Black Widow, and this one says better go to the ER. The hobo spider just says ouch, or we say ouch when we're bitten by it. So the behavior of this method will change depending on which value has been passed in. All right, finally we have a person class. And they have a method called happy birthday that increases that person's age by 1. So this is very similar to our body count thing. So we do person.prototype.happybirthday. And then we can do this.age++. So if I create I can give myself a couple birthdays. Man, the rest of my 20s went by so fast. And then if I look inside of this object, I will see that I have a typo somewhere. Oh, wait. Now, what did I do? Oh. Let's try that again. And my age has been incremented up to 30 because I called the birthday method twice. All right, so now that we've explored the idea of classes and prototypes, we actually can get a deeper look into what's really going on in JavaScript. So it turns out that everything is an object. So at the very beginning, I said, this thing is called an object literal. The reason that we clarify the difference between an object and an object literal is because behind the scenes, actually everything is an object. So strings, secretly objects. Arrays, also secretly objects. Booleans, objects. Now, the fact that they're objects is kind of masked from us, and it makes our user experience better as programmers. But it's good to know that these things behind the scenes, everything is built out of objects. So learning this class stuff, it's kind of like you become the god of JavaScript. because you're using the same tools that the JavaScript developers use to build everything else, to build your own customized data types. The other thing that we can keep in mind is that, as I alluded to, all of these data types like array, object, they all have prototypes and methods built in. So knowing how the prototype works means we can kind of do some sneaky things. So check this out. If we want to create a brand new array method, all we have to do is do array.prototype. Let's do something called getSecond. So this will, because we're putting it on the official array, this array with capital A is the array constructor, because we're putting it on the prototype, and we can just return this at 1. So we're saying whatever array we're working with, return the item at index 1. Now every array has this. So our monsters array has a getSecond method now. We literally just created it. Did we? Oh wait, I think we have to, yes, we have to do this before we create our array. Let's try it now. What did I do this time? It was going to be so cool. But what's going on? I've definitely done this many times before. Huh. That's so weird. Okay, monsters. If we do monster.prototype. Oh wait, array.prototype. Sometimes REPL, I mean, I don't think that that's what's going on here, but that's really weird. I can't seem to figure out what has gone wrong here. I don't want to waste the rest of class. Oh wait, okay. Now, did it work? No, I deleted the code. It shouldn't be singular because I'm actually trying to reference this array here, monsters. Still not working. Very strange. I wonder if it might be a Replit issue because Replit just updated. So I'm going to try one more thing. I don't want us to get too derailed because this was kind of just a side note. But Replit just made a bunch of changes. So I'm wondering if it actually prevents us from doing this now. That's my only guess because unless I've done something really stupid, I've done this a million times and I know it used to work. So let's try that. And then we can try oh, nope. I swear I know how to JavaScript. Oh, there it is. Yeah, I think that in Replit's new update, they don't want you to do this anymore. But in the real world of JavaScript, you can definitely do this. Cool. So anyways, that was a way bigger detour than I intended, just to show you that this whole stuff that we've been working with tonight is what's happening behind the scenes in JavaScript. So, all right, we still have a little bit of ground to cover, so let's go ahead and move forward. Let's talk about inheritance. So one more topic with constructors. I'm going to create us a nice little bird class here. So let's go ahead and create bird. Birds are going to have type and call. All right. And then we will do a nice bird.prototype.speak. All right, so birds, they have types, they have calls, and they have a speak method. So if we create a raven, we'll add an exclamation point on the end there for fun. All right, we have a raven. We can check out a raven. It's got some properties. We can do raven.speak, and it will caw. Okay, so what if we wanted to create an owl? Well, pretty simple. We could just create an owl the same way we did raven. But what if instead we actually wanted to create a bunch of different owls? So we wanted a snowy owl, and maybe we wanted a barn owl, and so on and so forth. We wanted like 10 owls because owls are really cool. So we're starting to get a little repetitive here. But what if we wanted to add a couple other properties or methods on here that are owl specific? Well, now we're starting to break down, and it seems like we might just want our own owl class. So we could create an owl class that's totally separate from the bird class, but the owl class and the bird class are going to share some features. So it'd be nice if we could kind of combine them. This is where inheritance comes into play. So we can actually create subclasses, so subcategories. An owl would be a subcategory of bird. So instead of doing this, we might create an owl instead. So let me show you how to do that. So it starts out looking very similar. So this is going to take a type. We don't need a call because the call is always going to be hoot. So what we would actually do is run this fun little thing. We'd say bird.call this type hoot. So the call method, it's a way of kind of forcefully passing arguments in here. And what we're doing is, what's actually happening behind the scenes with call is a pretty sophisticated thing, but essentially what we're doing is when we use it in this way, is that the first parameter should always be this, and then these next parameters are the parameters from bird offset. The type matches that, and then we're going to hard code in hoot as our call. So what will happen is our owl will automatically have these properties. So yes, I know not owls hoot. As I was prepping for tonight, I was like, but not owls, all owls hoot. And then I was like, whatever, just you don't mess up your example. You're going to spend all day overthinking this. But last time I taught this, there was like a 5-minute discussion about the difference between venomous and poisonous. So I get it. We're all programmers. We're detail oriented. It happens. So what happens now if I do snowy owl and I say new owl, and all I have to do is pass in this. So check this out. Because of this weird little call thing, it's actually created a subversion of my owl. So my owl still has a type and a call. So this line, I know it's confusing, especially as you're just getting used to the idea of this. So I would highly recommend for now for inheritance, don't overthink this. Just look at whether it's this replit or the examples in training kit. Just look at references, but be aware that this should be the parent. So this is the parent class, .call this, and then the second, third, fourth, etc. arguments should match the first, second. So these arguments map. It's just that what was first here becomes second here, and so on and so forth. Slightly confusing, I know, but when we learn how to do this Wednesday, you'll see some nicer ways to do all of this. So now we can create a bunch of different owls. And we can even, let's create our barn owl real quick. And we can even start to make some alterations to the owl class if we want to give it some extra stuff. So let's say that we wanted all owls to have a property called this.wise, and it's always set to true. We can do that. So we're not limited to the properties from our parent. We can add our own custom ones too. We could also add, oh yeah, let's talk about the prototype too. So right now, if we do snowyowl.speak, what do you think snowyowl.speak will do when I run this code? Any thoughts? We put the speak function on the bird prototype. So do you think this is going to speak correctly? So we think it's going to make a hoot sound. Actually, it doesn't. So the problem is that the snowy owl, when we do snowyowl.speak, it's going to look inside of owl's prototype. And right now, owl's prototype is a little sad. So owl's prototype is completely empty right now. Yeah. So nothing in there. So there's actually one other step we need to take whenever we're doing inheritance. So the two pieces of inheritance are call the parent constructor and copy the prototype. So this is where we don't want to actually assign in the prototype. So we don't want to directly point the prototype to the same one as bird.prototype. And this is what we talked about at the beginning, because now these two are linked. And if I change something on owl's prototype, it'll change the parent. So we want to make sure we use object.create so that we copy it. So we want to clone the prototype, not reference them to the same thing. Because now we're free to customize our prototype. So we could say owl.prototype.getWisdom, which is an owl-specific method. The ravens can be pretty wise too. And then I looked up some owl wisdom before class. We could return this mad owl wisdom here. So now if we do snowyowl.speak, or sorry, .getWisdom, we can get some nice owl wisdom here. And speak will work as well because we have successfully copied the prototype from the parent. So that's really the two critical steps, is we need to call the parent's constructor and copy the parent's prototype. I found when I was first learning this, I found this impossible to remember. So it's just a lot of random stuff. So I would highly recommend looking at references when you're doing this. And as mentioned, we will learn an easier way to do this on Wednesday. All right, so we are running a little low on time. We might go slightly over, but let me give you you might not get through this, but I'm going to give you 3 minutes to practice some inheritance stuff. Okay, so it says that Replit deleted 30 minutes of work. Make sure you have autosave set on or you're saving frequently, because that will help prevent that. I know that Replit can crap out a bit, but if you just save frequently, it's going to save a lot of, you might lose a minute or two of work, but just get in the habit of saving. But I'm sorry that happened. That's still frustrating. All right, so here is an inheritance challenge. I'm just going to give you 3 minutes on this because we have one more thing to cover after this. All right, so let me set the timer for 3 and I'll see you back then. All right, wrap that up. Like I said, if you didn't finish all of it, that's totally fine. So we want to, first thing is we want to create a subclass of watch called calculator watch. Should have the same properties and methods as watch, as well as a method called add. So notice that our watch has a brand and it also has a get time. So 2 steps to inheritance. The first is we have to call the parent. So calculator watch should also take in a brand. And then what we can do is we can do watch, the parent, dot call, this, and then brand. So the second argument here is that first argument from watch. And this is such an awkward bit of code until you're used to it. So once again, just look up references. And then that's all, at least for the constructor. Now the next step is we have to copy our prototype. So calculator watch dot prototype equals object.create, which is what creates a copy of the object, watch.prototype. And then finally, we want to add a new method onto this prototype, which is the add function. So theoretically, what we would want to do now is create an instance of calculator watch and test that all these things work. In the interest of time, I am going to skip that. But trust me that instances of calculator watch will have a brand, they'll have a get time method, and they will have an add method. Once again, 2 critical steps. Call the parent constructor and copy the parent's prototype. All right, so we need, in challenge 2, we need 2 subclasses of vehicle called car and motorcycle. They both should have the same properties and methods as vehicle, except cars should have 4 wheels and motorcycles should have 2. All right, so we see that vehicles have wheels, mileage, and a drive method. So when we're creating car, we know that we need to take in the mileage because that's going to change. And what we can do is do vehicle. This is the call the parent step. Dot call this. The first thing is wheels, which is going to be 4. And then we can pass in the mileage. And then, of course, we have to copy the prototype. So car.prototype equals object.create vehicle.prototype. The ++, this is saying add in this new value. So this is the same as saying assign this to the current value plus the new value. It's just a shorthand for that. All right, so we've completed our 2 steps. We've called the parent constructor and we have copied the prototype. I'm going to do a little copy paste magic because the motorcycle code is very similar. Motorcycle. The only thing we really need to change here is that it should be 2 wheels instead of 4. Once again, I would like to create instances of both of these and demonstrate that they are correct, but in the interest of time, just trust that this is how you do inheritance. All right, we have 10 minutes left. We will go slightly over tonight. I want to answer any questions you have on inheritance, and then we're going to talk a little bit about the theory behind the keyword this, talk a little bit about the homework, and we will be done for the night. So let's see, questions about inheritance. Anyone? All right, moving on then. And if any questions do pop up, I will do one last Q&A before we call it a night. So let's talk about some theory. So on the training kit page, the very first thing it talks about is these 4 principles of the keyword this. And these principles are nice to understand, but I'll admit, I thought it was a little silly that these were the first things in training kit because the keyword this is hard to get the hang of. And to me, there's no way you're gonna understand the theory until you've worked with it a little bit. So my hope is that we've spent a chunk of time tonight playing with a few different ways to use the keyword this. Now we're gonna tie it together and talk about, in a formal sense, what are these principles of the keyword this. So the first one is the global binding. A little scope reminder, anything that's declared out here in the wild is global. So global variable, console, global object, global. Whereas stuff that's inside a function, for example, if we created a variable in here, that is, we'll just call this example. So this would be a local variable because it's inside of a block. So just wanted to remind you about that terminology so we can talk about the global window binding. So if I just went ahead and console logged the keyword this, what do you think it would refer to, right? I always said this is the thing before the dot, but now this is just out in the global context. So if we just use the keyword this out in global world, well, it refers to something called the window. And at least in the front end world, the window is actually, I think this is technically node inside of Replit, but that you don't need to worry about that yet. So if you are in the front end programming world, this refers to the window, which is like this giant, it's like the god of all objects. It's the object that everything in the front end programming world lives on. So remember how I said secretly everything's an object? Where are all those objects stored? In a giant super master object called window. I always feel like a weird, creepy sage when I teach this stuff because I'm like, there is an object that controls everything. It's called the window. This is not a very common use case of the keyword this. You wouldn't normally see it used to reference the window because it's kind of just a silly way to do it. And window does not have, yes, window is just like the force. And then the when you're in the backend world, that'll be like the dark side of the force. But yes, window has nothing to do with windows plural. It applies across the board. So you can use the keyword this out in global context. It's called the global binding, but you wouldn't normally do it. All right, so let's talk about the implicit binding. So global binding would be literally you just reference this, or you reference this inside of a global object, a global function. So if I did return this, if I reference it in a regular global function instead of a method, that would also be the global window binding. So the next thing we have to talk about is called the implicit binding, and this is a lot more of a common use case. We've already worked with this several times tonight. This is the idea of what comes before the dot. So if we have an object and it has a method, we're going to give it some very exciting keys, and the method just returns this dot key. Yep, so this is what we've been working with throughout tonight. It's called the implicit binding, and it's the idea that when we call a method, this will reference whatever comes before the dot. So if we just returned this, it would actually return the entire object. So the implicit binding is, I think, probably the most common use case of this. This idea that this becomes the value, the object that the method is being called on. So when we're defining methods inside of our prototypes, it's the same binding that we're using, the implicit binding. We trust that when the method is called, it will bind to whatever instance we're working with. All right. The next one is called the new binding. So we've also worked with this one tonight. That's the idea that when we create a constructor, that we can just use this out in the wild, right? So we're using the keyword this slightly different when we are creating a constructor, because this will not be bound. Notice that this function technically exists globally. So if we really think about it, this exists globally. So this should actually refer to the window. But if we use the keyword new, that will change. So the new binding is the idea that when we create a new person, that instead of referencing the window, then that's what would happen if we ran this thing regularly. What'll happen is that this constructor will actually create a brand new instance, and this becomes an instance. So this references an instance, which will be returned as long as we use the keyword new. That's the new binding. So this is all, you've seen most of this before. I'm just kind of giving you the theory and the official terminology for all of it. And then the last binding, which we actually have seen as well, and this is kind of the weirdest one, is called explicit binding. And explicit binding is just saying that we can force binding. So we can always say, so remember we had this example object method. So if we did example object, is that what it was? Okay, so this is implicit binding, right? This refers to what's behind the dot. But what we can do instead is we can actually use call, and there's a similar method called apply, and we can bind this to something else. So we could bind this to window instead. Oh, dang. That's right. We don't have a window inside of Replit. Let's bind it to vampire. Why not? We have a vampire somewhere in here. So what happened, this is really confusing stuff here and kind of not maybe the best thing to talk about at the end of a 2-hour lecture. But what's happening here, let me change. So let's do this. Name equals example object. So let me show you what's going on here. And I'm even gonna copy this down here so we can see it. Referenced. So let's just, okay, so we created this example object, and normally what would happen is if we called the method, let's do return this dot name. So if we call our method, it gives us, let me try this. What? Oh, right. I have to change it. I have to change it in the real version too. Okay, we got this. Just a few minutes left. So if I call the method on the example object, it's going to give me the name of my example object, right? Because this ends up referencing example object. But we can force it to reference something else by putting call on and passing in a different object. So we're basically forcing this method to now act as if it were bound to the vampire. Really weird stuff. So this is definitely the most advanced use case of this. I don't expect you to fully understand this right now, but be aware it exists, which is that you can actually force the binding of an object using call or apply. So the one place we've used this already is in inheritance. When we're actually calling the parent constructor, what we're doing is we're creating a bird, but we're forcing bird to be bound with an owl instead. So once again, this is really confusing stuff. You don't need to understand it on a deep level. Just know that the fourth and final use case of this is called explicit binding, and it's where we can force this to be bound to different items. And there are some really cool use cases for this, but I would just practice getting really comfortable with this new binding, which we use when we create constructors, and with this implicit binding. These are the two most common use cases and the ones you really need to focus on right now. So there's a little bit of some heady theory for you at the very end of class. Let me talk about the homework real quick, and then I will do a final pass through Slido for questions. So here is the homework tonight. It's a lot more lightweight than the homework of the last 2 nights. So take your time on it. Make sure you understand things. You won't be rushing through this one like you have been. So that's a nice little change of pace. One note is that there are two different ways to complete this. You can complete it the way you have been using get and VS Code, or you can note that these are options. You don't have to do both. It's the same thing. Or you can use something called Code Sandbox. And what's nice about Code Sandbox is it makes debugging a little bit easier. So if you're happy with your flow in VS Code, feel free to do that. But if you want to try something new, just go ahead. You can go ahead and create a Code Sandbox account. It's really easy. You can do it with GitHub. And it's just like a browser version of what you do in VS Code. But what's nice is the tests appear in a much more pretty, easy to read way than they do on the command line. So that is really the only benefit of doing it this way, is that your tests will be all nice and pretty like they are over here. So either way, whichever you choose to do. And just note that you have a couple constructors to build, some methods to build, and a little bit of inheritance to work with. So yeah, much simpler stuff than what you've been doing. Or maybe not simpler, but there's just less problems is really all it comes down to. So yeah, take the time. If you have extra time, maybe go back and review some of that craziness from last week. So let's do a final pass through on Slido, and then I will let you guys go and get started on this. All right, how do you select and change several objects at the same time? I.e., you selected one word located in several places on the code and changed one, which changed the rest. So I think you're talking about when I change things in the constructor. So let's actually go over here. If we decided that poisonous was a better word, instead of having to alter, because notice both spiders have this property, all I would have to do is change this to this.poisonous. I could even keep the argument named the same, though that might be confusing, or sorry, the parameter, and it would change on both objects. And if I had 10 spiders, it would change on all 10. So this constructor is like the master source of truth for all these objects. So you can change one thing on the constructor and it'll change for all the instances. Can you assign object.createParent.prototype to a variable? Sure, if you wanted to, but I don't think it would benefit you. There's no rule against it, but it wouldn't help with inheritance. You really want to assign it to child.prototype for inheritance to work. But if you ever wanted to store the prototype somewhere else just for fun, there's nothing stopping you. Can you do this? Example object method.call this. So yes, and it would, let me show you what that would do. So if we did object method call this, this is going to be bound to the global scope. So we're going to end up with we are going to end up with undefined. And that's because our global this does not have a name property. So this gigantic object here, there's no name property. And specifically, this method is looking for a name property. But it still works, and that's what's being bound to. So if we did this.name equals global object, now it's going to work because we've given our global this a name property. So, all right. Can you cover the subclass topic, specifically the significance of this? That would be, so we can talk about it a little more, but honestly, it's such a heady topic that I feel like is not necessary right now and might create more confusion, but I'll try and just cover the basics of it without digging in too deep. So I'll talk about what's really happening, though I might not fully explain why .call creates this. So what happens when I call this line of code is essentially all of the vehicle code runs. So the vehicle code runs, so we create an object that has wheels, and wheels is going to be set equal to this parameter. And then what it's going to do is run this line of code and set that equal to this parameter that's being passed in. So it's creating an object by the specifications of the parent, but with these two values. So then what it does, and this is where the whole binding, because this is bound to the car, is this, instead of being an instance of vehicle like it would normally be, this becomes an instance of car. So it creates a vehicle using the argument starting with the first one, but then instead of assigning it to the constructor of vehicle, the binding here assigns it to the constructor of car instead. And then it will spit it back out, and so that we can actually start to add other properties to it if we want. Okay, what is inheritance in JavaScript and how is it useful? So this could open another big rabbit hole to talk about what is object-oriented programming. So I think we'll get a much better explanation of this in class on Wednesday, so I don't want to go in too much. But essentially, when we think about why are classes useful, classes are useful because sometimes we want to create a bunch of similar objects of the same format. That's why we create classes. The reason we create subclasses, in other words, inheritance, is if we want a slightly different version of those types of objects that we've been creating. So it'll help us keep our code dry. It'll help us manage a bunch of different objects that look similar. But the real answer is way more deep. It turns out that there's an entire paradigm called object-oriented programming that surrounds making everything into classes. Lots of languages do, like Java or C, do everything this way. And so it's kind of JavaScript's way of mimicking these other languages and allowing you to use this paradigm if you want. That is the long answer, and we'll talk more about that Wednesday. And yes, I will save and share my guided replets. All right, I think that is enough for tonight. So let's call it a night. Good luck with the homework, and I will see you guys all on Wednesday. Have a great night.